Sometimes you do have lot of data in front of you, but by just looking at the data, you really can't say anything out of it. You can't really say that, okay, if this is my data, can this might be a meaningful information or pattern I can make out of it. It is impossible for you to do that if you have especially a very huge amount of data in front of you like that. Now, in order to solve this, what we can better do is, how about if I can present that raw data into a graphical format? Means, can I represent it into form of pictures now? If I can somehow represent a raw data into pictures, into some sort of graphs, then it will start making more sense for me. Maybe I can find some very interesting pattern out of it if that's gonna be the case. So for doing this, we do have something called as Matplotlib library, which is available in your Python. And this is going to help you to very effectively visualize your analysis and can sometimes even help you in getting some hidden patterns out of your data. Now, there are majorly two packages which are very famous. One is your Matplotlib and second is a Seaborn library. Now, Seaborn package, if we talk about, is built on top of Matplotlib only, and they can be very well used together if required. And we will see to that in further lectures that how this is going to be useful. In fact, you will notice that with Seaborn you can perform much more advanced functionalities which you cannot perform on Matplotlib. So let's start with a very basic plotting mechanism. We will see that how to basically work with respect to this data. Now what I have done in this case, I have created a two numpy arrays which is having total 100 values. So we have almost 100 values in both the arrays x and y, and first array is having the value between 5 to 100, all linearly spaced, and second numpy array have the value from 10 to 1000, again all linearly spaced. If I just use this plot, now this plot is coming from this import package Matplotlib. Now one more thing, if in case this is going to throw you an error, import matplotlib.pyplot, if this line throws you an error, just go ahead and say pip install. So say pip install matplotlib. Okay, so this is what you need to execute in order to install Matplotlib. If pip is, you have done the installation not by pip method but by using anaconda, then you can say conda install matplotlib. So if you do this, this is gonna help you to install this particular package. Now here we have created this and then we are saying this. So if you look at this part, I have taken plt as a reference to matplot.pyplot. Now here I will say plt.plot and I'm going to pass this x and y, and what this is going to do is this is going to create a graph for me. But if I execute this right now, you will notice that this is not going to give you any result. Let me show you. So right now when I have executed this, you can find out that basically this is just going to give you this sort of result, and you can see this particular output from it, right? So now, so basically here how the plotting have happened, you can notice here that I do have basically x value as 5 and the first value for y is 10. So it might have plotted here 5 comma 10, right? This is my starting point. Similarly, it might have plotted on x and y axis. So this is your y axis, let's say, and this is your x axis. So it might be plotting all this point here, and in the end it have basically showing up that all the lines are very linearly kind of linked with each other. So if you just put all these dots which I got from all these points, then this is going to throw me this sort of line for us. This is what this is going to return for me. Now similarly, this dot show is required to represent and see this graph. Okay, now here I have done again a random data, and you can see a very interesting thing out of it. In this case also I have like 1 comma 4 comma 6 comma 8. This is my x-axis. So, and on the y-axis, this is my 3 comma 8 comma 3 comma 5. So you can see that I'm going to plot first, in this case 1 in my x and 3 in my y. So 1 comma 3 is what I'm going to plot first. Then 4 comma 8 is what I'm going to plot next, which is going to be 4 comma 8. That's the reason this line is going like this. Then 6 comma 3, which is 6 comma 3. So I have my third point here, and 8 comma 5, which is my fourth point here. And that's it. It have just plotted all these things together, and given you this particular graph. So this is a very interesting way how you can get all this plotting and can help you visualize some data. Now let me show you one more interesting thing. So you are plotting this data, that's one thing, but you can also define few more labels and name of the graph, all these things as well. For example, you can say plt.plot x comma y. This is basically help you to plot the graph. But let's say on the x-axis you want to give a name current. You can see that on my x-axis I am giving a name current. Similarly on my y-axis I would like to give the name voltage, and the name of the graph I may want to give as Ohm's law. So let's go up and see that whether we are able to do it or not. So you can see here with the x label I can just pass current. Y label is gonna give me the y axis name, which is voltage. Similarly, title of the graph I'm giving it as Ohm's law. Now I am also telling that my limit for my x and y means, you can see here that I'm telling that start my x-axis from 20, maybe not from 0 but from 20, and end it at 80. Similarly, start my y-axis from 200 and end it at 800. This is what your x-lim and y-lim is going to do for you. Okay, so if you do this, this is gonna print out this particular graph for you. Now let's look at few more things. Now what I want to do as a next step is, I would like to plot this graph, but this time if you notice, I'm first of all plotting this crosses, not a line. Secondly, this crosses is into blue color. Now if you look at this part, this sounds very familiar to you, right? This is very familiar, which we have just seen. X-axis name, y-axis name, graph name, and plotting the graph. Look at this part. I am plotting x and y, okay? And this blue plus basically means that I am basically going to draw a blue line, and plus that should be like plus. So that's for the reason it was sounding like a cross above, because it's a plus symbol. So here what it have done is, it have just gone ahead and created a blue color line for you. And you can see here my x and y we have initialized. X is basically nothing but having 20 values from 0 to 10, and y is nothing but the square of these values. And that's what I have plotted with a blue line having plus kind of option. So this is how you can plot your values in this format. Now similarly, what I could also do is, like you can see in this graph, I can plot 3 different lines, all of different colors. Here in green color I want to plot triangle, I can do that. Blue color I can draw this plus, I can with the blue color, and this red color is a line. So let's say I want to do something like this in the same graph. How can I do it? So you can see here that x and y I have created again, and what I am doing further to this, I am just looking at plt.show. I am passing xy. So I am telling that red, and remember I put a dash, dash means line. So create a red color line. Then again I am saying comma x comma y square. That's the reason you can see that this is going like a little in the shape, right? This is y square. So now I'm telling that that should be blue color, and it's a plus symbol, which you can see again coming up. Then x comma y cube, this should be my third plot which I want to create in the same plot, and this should be of green color, which is g, and the symbol is this triangle. So this is how you can basically print out this sort of graph. Within the same graph you can plot different type of lines or triangle or whatever you want. Now we do have a few more interesting thing when you're going to work, especially with respect to your Matplotlib, that you can always create even subplots within it. What I mean by subplots, let me show you an example of it. So you can see here that in this case I have drawn 2 plots, like one plot and another plot. So this is 2 plots side by side. Okay, so one may be belonging to y as log x and second belonging to log x square. So how can I create such sort of graph for myself? Let's see in this particular case. Now you can see here it's very simple. Again I have to just get my x and y first. So y I am taking at log x first, np.log x. Now here I have to say that plt figure 1, okay, which basically mean that I am going to go and basically initialize, okay, basically I'm just initializing my figure in this case. Now after that what I'm doing, I'm basically telling that plot dot subplot. What does this mean? Now if you look at this, my graph was like this. Now if you think of it in a tabular format, how many rows you have? 1, right? 1 row. How many columns you have? 2. So that's what will be represented here. 1, 2, okay, means 1 row, 2 columns. Now which graph you want to start? first graph out of it. So that's what you would say 1. Okay, that's how you will represent it. You want to see for this part? Let's see this. Again, I have 1 row, 2 column. Let me put it here. Okay, now I am plotting the second graph, so 2, like this. Okay, now within this you need to just tell that what is the graph you want to plot. So you are saying that plot dot title, this is the title name, and this is the plot you are plotting x comma y. Then after that you again created plot dot subplot, and then inside that you are telling your title of the graph, you are telling the plot which you want to plot, and just say dot show. So what this is gonna do, this is gonna create a subplot for me, means two graphs being together. That's how you can always do it in this way. Don't you think this is going to be very interesting? Yes. Now let's see a few more examples. Now let me create more complex graph, maybe with 4 subplot, which will make even more sense. You can see here that I have created like 4 graphs, means 2 rows and 2 columns. So 2 will definitely come. So linear, cubic, log, exponential. I would suggest that pause this video at the moment and try to plot it on your own. This will give you a very good idea that how to plot this sort of thing. So that would be my suggestion, but you can now you can look at the solution here. So you can take your x, you can just initialize your figure so that you can plot something. Now you are saying that 2 comma 2 comma 1 linear means 2 rows, 2 column, and the first graph we want to plot. Put the values to it. This is going to draw a linear plot for you. So you can see here, this is going to draw a linear plot. Then after that you want to plot this, so it will become 2 comma 2, which is 2 rows, 2 columns, and this is the second graph. So this is going to be what? 2 comma 2 comma 2. So you can see here. So I'm just saying 2 comma 2 comma 2, and this is gonna return you basically the second part. Now for this, now how you will distinguish this with the second part, right? Because this is basically, so what you should say, my question is, now this is 2 comma 2 comma 1, this is 2 comma 2 comma 2, but what about this? Should I say 2 comma 2 comma 3? No, you can't say this. So in this case, what we do is, remember when we were initializing it, we were saying figure 1, figure 2. So this figure 1 was talking about this part, first row. So now if you want to go to the second row, you have to say figure 2, and then this will become 2 comma 2 comma 1. Now it means that come down to the second portion of your graph and then plot it. Let me show you. So here, if you go back and see this particular portion, so you can see here that when I have done this for the cubic part, I have to say plot dot figure 2, right? So which was then basically you can say 2 comma 2 comma 1. For the third graph, you can say 2 comma 2 comma 1, not 2 comma 2 comma 3. Okay, that's the difference basically here. You can see here this was figure 1, this was figure 2, and then again for the last part exponential, you can say 2 comma 2 comma 2, and this is gonna create basically another graph in this case for you. So this is the way you can always create lot many graphs together. I would suggest you to now again stop back if you were not able to do this. Create a graph for me with maybe 3 by 4, which have 3 rows and 4 columns. And you can put whatever way of graph you want. This is a homework exercise for all of you. Please try this. I would strongly recommend you to please hold on here. Do not move ahead. Please create a graph with 3 cross 4, 3 rows and 4 columns. Put whatever value you want to inside it, and then create a nice graph, and this will give you a very good insight that how these graphs are being created together. Now let's look at some more type of graphs which we do have with us. For example, we do have something called as box plot, histograms, scatter plot, and bar plot. Let's see that how they gonna be also useful for us. Now in order to do this, I have taken a data set which is market underscore factor.csv. Now this data set will be available for you, so you can use this data set for your practice. Now this contains like your lot of details like order ID, product ID, ship ID, customer ID, sales, discount, profit, and so on. Now what I'm gonna do using this data set, I'm gonna do some plotting. So let's say I want to plot a box plot. So box plot is going to look something like this. So what I'm doing here is I'm plotting a box plot only on the column order underscore quantity. I want to analyze that how much is quantity, how my quantity data is distributed here. So maybe my quantity data is somewhere starting near to 0 and ending up near to somewhere 50. Now this graph looks like this. This portion what you see is representing your median value. 50%, 50th percent of the data, right? Remember that quartile and all those discussion. So this is basically the median of the part. Now this is a first quartile. This is basically these are basically your quartiles which you have, and anything above which is sometime goes, basically you can call it as outliers. Okay, so this is a very nice representation. So this tells you that okay, whether the data is more in the lower half, whether the data is more on the upper half, right, whether we do have any outliers. In this case we don't have any outlier, but we will see a lot of examples where we will be having some outliers coming up, and that's where we will see that how to fix even those issues. So this we have done it for order quantity. Let's plot a box plot for sales now. Now this box plot, if you look at, we are not able to even visualize it at all. Why? Because maybe the data distribution is pretty much at the higher end, because you can see that this is showing at the outlier. And if you want to confirm it, you can do a describe and see this part. You can see the minimum value you have is 2.2, and your 25th percentile is somewhere around for 143. But you can notice on this part, that's we have a huge jump, right? That means it's a huge outlier, because even if you look at the 50th percentile and compare this value with this value, that means after 50th percentile there's a huge chunk of data which is there. That's the reason we are seeing that graph in the upper portion. We are not able to visualize anything out of that graph. Now what is the solution for it? One way to handle the situation is that we take the log on the y-axis. If we do take the log of y-axis, what will happen? Your very high value will scale down to be lower, and we will be able to visualize the graph. You can see this here. So what I'm going to do is this left hand side graph, what you're seeing is your normal graph, and the right hand side graph, what you see is the logarithmic scale. So you can see here that I'm just saying y scale as log, means on the y-axis just do a logarithmic for it, and this is the same for sales data, but this is much more understandable, and we can easily see that how my data is looking like in this particular graph. Now let's look at another plot which is called as histogram. In histogram, as you can see that it is going to just look at that what is the amount of total amount of data being present here. So this is the count of data maybe for the values between 0 to let's say 5. So they are like 8,000 in number. Similarly for this, how many numbers are there? So this y-axis represent your count of data, and x-axis represent the actual data what you have, right? Or you can give a range if you want to. Now, so in this case, what I have done, I have plotted it for sales, and again you can see this was expected from box plot that most of the things are falling here for one of the range. It is falling at very high value. Now if we look at this, so better is that we y scale the data, and you can see that we are logging up on the y-axis, and now the graph is making much more sense. In fact, right now I'm just explaining you about this graph, but later what I'm going to do is, while I'm going to talk about exploratory data analysis, you will notice that I'm going to start making a lot of sense out of this data when we are going to solve some sort of case studies in those cases. Okay, now scatter plot is the most interesting plot, where you plot this x comma y, means let's say you're plotting on your x-axis sales, y-axis profit. It is just going to plot all these points, and we can see this data. Now again, this is very interesting. You can see that we have maximum of the data being centric around maybe 0 to 20,000, right? So that's what we can see in this case. Now similarly, if you let's say have any sort of image with you, let's say you have an image called as country_analysis.png, and you would like to just go ahead and see this data in your Jupyter notebook. So you can do that by using this imread function. So you can say plot.imread and then say show and pass this image to it. You will be able to see that particular image in your Jupyter notebook. Now you can see that what is the type of that image. It's going to be numpy.nd array only, because it's going to be represented as 0101 format. Similarly, you can see the shape of this, like what is the dimensions of your image. It's a 3D dimension data because it's a colored image. Now what is the type of the data? Float. Now similarly, you can, if you print this image, it will return you that 0101 kind of value, which you can always see and can use that. Now this is the basics of Matplotlib, which is basically helping you to understand a lot of concepts like box plot, scatter plot, even so many other plots we have seen. But later we gonna start using it, as I said, and we will learn about much more another method going forward from the next lectures.